Namaskar, my dear friends. Let us start with probability. So what we'll do is we'll try to cover all the topics that is being asked in GATE under probability. So let us start with topics that we will be seeing. So first of all, we'll see probability basics. Like what is the probability, how to find probability of an event, all those things we'll see in probability basics. Next, we'll see conditional and independent events, like what are the different kinds of events. Conditional and independent event. So you can make a note of all the topics that is going to be covered so that you have these in your mind, right? Next, very important one will be random variables. Fourth one will be probability distribution. Fifth one will be, we will talk about curve fitting. It is not under probability, but it comes, like along with it. So curve fitting by using the method of least space. Okay. So these are the topics that we will cover under this probability topic. Now let us start with some of the terminologies that we will be using quite frequently. Okay. So very first thing that we are going to talk about is random experiment. In random experiment, what happens is an experiment whose results are uncertain, like you do not know what is the result that is going to come for the experiment that you are conducting. So you can write it down, an experiment whose results are uncertain. Next is we are going to talk about outcomes. So what is the outcome? Outcome is nothing but whatever result that you are getting of an experiment is your outcome. So you can say result of an outcome. So why I am talking about outcome is whatever the result that you are going to get, that is your probability of an event, right? So what is the probability of getting something uh, on your side? So all these result of an experiment, not outcome. Result of a random experiment. All right. Next is going to be sample space. So what happens is, suppose you conduct an event, you conduct an experiment and you have 10 results. So out of all the 10 results, some are, like in your favor, some are against you. So put together all of them is actually called as sample space, right? Whether it is against you or in favor of you, that doesn't matter. You can say, let's say sample space S is going to be set of all outcomes. Set of all outcomes. So I'm going to write some notes, and you can understand by this what is this probability means. Okay. So let us say number one, if a coin is tossed n times, let's say we have a coin and that will be tossed n times, what will happen? The total number of outcome will be 2 to the power n. So you can write it down. If a coin is tossed n times, or n coins is tossed are tossed at a time, then the total number of outcome is 2 to the power n. How? So let us say one coin. What is the result that you are going to get? 2, right? Head or tail, head or tail. So let us say 2 coins. So what will be happening? You have head, 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 tail, 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 head. So 4. So basically it will be 2 to the power 2. Similar to that, 2 to the power 3 for 3 coins. Like that, you will be getting total number of events, okay? Or total number of outcomes. Got it? Let us say next point. If a dice is thrown n times, if a dice is thrown n times, or n dice are thrown at a time, then the total number of outcome is, so can you tell me what is the number of outcomes that is there on one dice? So one dice you have total number of 6, 1, 2, 3, 4, 5, 6. So total 6 outcomes is there by one dice, right? So if you throw it n times, the total number of outcomes will be 6 to the power n. Okay, similar to the coin, it was 2, right? Head or tail. So 2 to the power n. It is 6 to the power n. Got it? Now let us talk about what is my event and what is my favorable event, right? So if we talk about events, so whatever the sample space that is there with you, the subset of a sample event or sample set is called as event. So you can write it down. Subset of sample space, which is, let us say, S, and it is denoted by E. E means event, or you can write it down like E1, E2, E3, like that. You can also write it down or A, B, C. So basically these are all called as events, okay? Now can you tell me what is my favorable events or favorable cases? So in favorable cases, you can see the set of all these outcomes or all the events which are which causes occurrence of an event. Okay, let us say I'm going to write it down like this. The set of the set of outcomes, we have total number of outcomes in sample space, right? But out of that, which are the set of outcomes which causes the occurrence of event, like we want something and that is causing that to happen, okay? Which causes the occurrence of the event. You understand? One more time. Like suppose we want some event to happen, and the set of outcome that is there which is telling that okay, it is going to happen, it means it is my favorable case, right? So let me give you an example. Favorable case, right? So in favorable case, you can see For example, tossing a coin 2 times. So what will be the sample space? Can you guys tell me? Since it is 2 coins, so either you can get it head head, head tail, or tail head, or tail tail. So these are the four, outcomes that is going to come. Now let us say I am going to define an event E1 which is going to be exactly getting one head. Getting exactly one head. Now what are the what are the occurrences or what are the events that is causing to happen this? So as you can see very nicely from your sample space that how many events are causing you to get this one head, head tail and tail head, right? So you have head tail head. So this is your favorable case. Let us say you are going to define another favorable case, event E2, getting two heads. Like if you get two heads, you will win, right? So it means all those outcomes which are favoring this event is called as favorable cases, right? So out of these four, which one is telling you that okay, you will get two heads? Head, head. So this is the event set that is there with you. Okay. Now let us talk about another terminology which is called as mutually exclusive or disjoint events. Mutually exclusive or disjoint events. It means it is very prominent or very obvious that if you have two events, both of them are nothing having common. Nothing is common between two events or three events or n events. Then only they will be exclusive. Okay. So you can say it, you can write it down. Two events are said to be mutually exclusive if they cannot occur at a time, like nothing is common between them. If they cannot occur at a time. Understood? Basically, you are going to get, let us say we have two events E1 and E2. Then E1 and E2 will be null set. Null set means phi. Phi is null set, means zero values are there between the like a common of E1 and E2. Nothing is common. Like no common favorable case are for mutually exclusive event. You can say no common favorable case for mutually exclusive events. Understood? Now we are going to define our probability. With all this terminology, you understood what is event, what is outcome, what is experiment, what is sample space. Now is the time to define my probability. Okay, so probability is nothing but probability of occurrence of an event. Any event you define and you want it to happen so that you can, like keep it in your favor. So that is called probability. Probability of occurrence of event E. So if I am going to write down E, then I will write it down as it is defined as probability of E or if you put event as A, then probability of A, like that. So what is the probability of E? That is probability of event E, that is number of favorable cases, number of favorable cases divided by total number of outcomes. Total number of outcomes. It means what? You can write it down as number of events E divided by total number of events, that is number in sample space, Ne by Ns. This can also be written as small p, okay? That is probability of this event. So can you tell me, let us say I want to define this. What was the probability of E1? We had written that tossing two coins, getting exactly one head. So getting exactly one head, how many occurrences were there? 2. And total number of sample space was 4. So this is going to be 1 by 2. Similar to that, probability of E2, you can see that getting exactly 2 heads. So the number of occurrence was only 1 divided by 4. Understood? So this is how probability you get. So there are some rules for this probability. Number 1, you can write it down as for any event E, the probability will be always between 0 to 1. So either it will be exactly 0 or greater than 0. Probability of E will be greater than equal to 0 but less than equal to 1. It means if it is 1, the probability is certain, like it will happen. If it is 0, probability is uncertain, means it is not there at all. It will never happen. Let's say number 2. Number 2 is if probability of event E is 0. If probability of event E is 0, then event is called as impossible. Called as impossible. Why? Let's say if I am telling you the sun rises in the west. So west, it is not possible at all. It will never happen. So you are very certain about that. Probability becomes 0, right? Also, this particular thing is denoted by impossible event, right? And denoted by phi. So basically you can write it down, the probability of phi is equal to 0. Like if there is no event that is happening, the number of event that is occurring is 0, or phi, the probability of happening that is 0. Let us say third one. If my probability is 1, okay? If probability of event E is 1, then the event is called as certain event. E is called as certain event. Means it will definitely happen, and usually denoted by S. Got it? Let us talk about some more principles. So you can say, if I am telling you two events, let's say A or B. So A or B can also be written as A union B. Like in subset theory, set theory, you know, this is the symbol of union, or means union, okay? If you are going to talk about A and B, then it will be intersection. So A intersection B, that is common to both of them, okay? If I am telling you not A, means A should not happen. It means it can be written as A bar, or also it can be written as A complement. So any of these symbol I write, either this one or this one. You have to understand that A is not happening. Okay. Now if I tell you, neither A nor B, neither A nor B, then it can be written as A union B complement. Right? Means A or B is happening but none of them are happening, it means it is complement. Or it can also be written as A complement intersection B complement. Okay. So you must understand these terminologies. Let us say next one is, we'll talk about probabilities. So these were the events. Now we'll talk about probabilities. So probability of A union B. So how will you do that? So probability of A union B is nothing but probability of A plus probability of B minus probability of A intersection B. PB minus PA intersection B. So if they are mutually exclusive, then this will be 0. It means A or B is nothing but A plus B. So you can take down that one as this one. If A and B are mutually exclusive. Understood? Then probability of A union B will become probability of A plus probability of B. Why it is going to be? Because probability of A intersection B is going to be 0. Got it? Now let us say you want to find out probability of A complement, because you know already what is the probability of A, then what is the probability of not A. So the not A will be probability of A plus probability of A not is 1. So it will become 1 minus probability of A. You must understand that probability of A plus probability of not A is going to be 1. Why? What is the probability of happening A? Let's say some percentage 50%. So not happening A will be 100 minus 50%, that is 50% again. So it will become 1 definitely. Got it? Next is, if we have A is a subset of B, okay, then you can write it down. Probability of A will always be less than or equal to probability of B. So probability of A will always be less than equal to probability of B. Now if I tell you that probability of A intersection B is what is the probability of A intersection B and PA and PA union B? So probability of A will always be greater than or equal to probability of A intersection B, and it will always be less than or equal to probability of A union B. Okay, so this is the relation that is there with us. So why don't we do one thing? We solve some questions so that we can have a proper understanding. So let us say question is, if a coin is tossed 3 times, 3 times, the probability of getting 2 heads is, the probability getting 2 heads is. So can you guys take a moment and solve it and tell me what is the probability? Take 2 minutes of time and solve it. Okay. So you know already that it is very difficult sometimes. Like let's say if you have 2 coins, then it was very easy. Head, 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 tail, tail, head, and tail, tail. But if it is 3 coins, it will become much more complex. head, 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 tail, head, tail, head, tail, head, head, tail, head, tail. Like that, it will be keep on going. Okay. So total 8 events will be there. 7, and then what is remaining? Uh, head, tail, head is done. So yeah, this is how, like, you will be trying to make it, but it may be little tough. So you can write down another one will be uh, head, tail, tail. Okay. So these are the total 8 events. So basically I am going to tell like this: the total number of outcomes you can write. That is, number of sample space will be how much? Since one coin tossed, it is becoming 2. So 3 coins it will become in 2 to the power 3. That is going to be 8. So total 8 outcomes are there. You can see. Understood? Now we want probability of 2 heads. So what will happen? How many times 2 head will occur? So you can see, you can count. This is 1, 2, 3. So total 3 are there. So you can write it down, 3 divided by 8. So this is your answer. But the problem is what? You do not have a privilege to have this visualization every time, because if number of times increases, it will be very tough for you. Okay. So what is the possibility? You can do one more thing, that out of 3 coins you need 2 heads. So I can write it down, 3C2 divided by 2 to the power 3. Because we need 2 heads, so I can write it down. What is the probability of getting 2 heads? So out of 3 coins we need 2 heads. So 3C2 divided by 2 to the power 3. So it's very easy now. What is 3C2? Factorial 3 by factorial 2 into factorial 3 minus 2, right? And like factorial n by factorial r into factorial n minus r, and divided by 8. So that is going to be, this will become 3 by 8. So this is the answer. Another way to do this one is, what? You can have one column as h, another column as head, tail, and you have 3 coins, right? 3 times tossed, right? Tossed 3 times. So just try to understand, otherwise you will not be able to, like, develop your own concept. So I want you guys to develop your own concept to solve this kind of problem. It becomes very easy once you know this. So there is a possibility that all the 3 are head, so tail will be 0. There is a possibility 2 are head, 1 is tail, and then 1 is head, 2 is tail, and 0 is head, all the 3 are tails. Got it? So you can say that my probability of 2 heads is equal to what? So can you guys tell me, 2 heads will occur how many times? So you can say the probability, this one is going to be what? Either it will happen head, head, tail, head, tail, head, or tail, head, head. So total 3 events are there, right? So you can write on 3 divided by total are 8. So this is the answer. Understood? This particular case will happen like this. Like, I need out of 3 I need, let me change the color. Out of 3 coins I need 2 heads and 1 tail. So 2 head and 1 tail is only these events. Can you guys solve quickly and tell me, coin tossed 5 times? Coin tossed 5 times. So what will happen? I need a probability of 3 heads. So now it becomes very difficult to make these 5 coins. You can write it down a table, let us say head and tail, and you have either all the 5 are head, then 4 are head, 3 are head, 2, 1, 0. So all 5 head, tail will be 0, 1, 2, 3, 4, 5. So the event that I want to happen is 3 heads. So 3 heads is this one, right? But keeping 5 coins, 3 will be head, 2 will be tail. The combination becomes very complex. So instead of doing this, what you can do is you can do 5C3 out of 5 I need 3 and then 2 to the power 5. So you are going to get what? Factorial 5 divided by factorial 3 into factorial 5 minus 3 divided by 2 to the power 5 is 32. So this is going to happen as 5, 3 got cancelled. So 5 into 4 divided by 2 into 32. So 4 32, 5 by 16. So getting 3 head when coin is tossed 5 times is 5 by 16. Let me give you one interesting problem here. Same question, like coin is tossed 5 times, okay? Tossed 5 times. Probability of getting at least 2 head. Probability of at least 2 head. So you know already probability of getting a 2 head was, I mean, you know, like 5C2 divided by 2 to the power 5. But if you need at least 2 head, it means what? Minimum 2 head, or if it, even if it is more than that, doesn't matter. So you can say this is going to be equal to, I need at least 2 head, means out of 5 coins I need 2 by 2 to the power 5 plus, even if it is 3 doesn't matter, so I can write it down 2 to the power 5. Even if it is 4 doesn't matter, like if I get 4 heads then also it is good, and if I get all the 5 heads then also it is good. So this is the answer. You can solve it by yourself. Understood? So what I mean to tell you guys is, if at least 2 times means 2 times, 3 times, 4 times, 5 times, all these happens, then doesn't matter. You can take all the events, right? Now I will give you some of the, you know, like outcome. So let us say, note, if a coin is tossed n times, coin is tossed n times, you can keep this in your memory by your you know, like very easily, because this is very very important. Probability of getting even number of heads, okay? Probability of getting even number of heads, that is going to be 1 by 2. It means what? Let us say three coins are tossed. What is the probability of getting 2 heads? So that will be 1 by 2. What is the probability of getting 4 heads? But the number of n which must be more than the number of your requirement, okay? Similarly, getting odd number of heads will be what? Getting odd number of heads, that will again it will be 1 by 2, because even number of heads are 1 by 2, then odd number of heads will also be 1 by 2. Let's take another question. So this was asked in GATE. Question is, a coin is tossed n times. Tossed n times. The probability that the difference between the probability that the difference between number of heads and number of tails is n minus 3. Heads and number of tails is n minus 3. So what is the probability that we get number difference between number of heads and number of tails? It must be n minus 3. The options are 2 to the power minus n, 0, nc n minus 3 into 2 to the power n, 2 to the power minus n actually, and d is 2 to the power minus n plus 3. Take a minute time and solve it. So how shall we do that? How shall we do that? So why don't you do one thing? You just try to have some experiment. Let us say n is equal to 7, okay? Some odd number. So what is the probability? We have head, we have tail. And let us say this is the difference that we want to find out, right? So either all of them will be head, 0 will be tail, or 6, 1, 5, 2, 4, 3, and 3, 4, 5, sorry, 2, 5, and 1, 6, 0, 7. So the difference between head and tail is n minus 3, that is going to be 5 minus 2, that is going to be n minus 3, right? Or otherwise 2 minus 5. So this is the two things. Another event is, let us say n is equal to 6. Then what will be the head and tail and the difference that we want to see? So either it can be 6, 0, 5, 1, 4, 2, 3, 3, and 2, 4, 1, 5, 0, 6. So is it possible to get n minus 3? Not possible, right? So here for even number of cases you are not getting n minus 3. For odd cases you are getting n minus 3, right? So now we will generalize this particular experiment or this particular thesis again. Let us do here. If coin is tossed n times, coin is tossed n times, so either it will be head or it will be tail, that you know. So either all the heads are appearing, you can say all n heads are there, 0 tail, or n minus 1, 1, n minus 2, 2, like that it will happen. Last may it will happen 2, then it will be n minus 2, and this will be 1, n minus 1, and it will be 0. So all n are tail, okay? So this is how you can see the distribution of head and tail based on coin tossed n times. So what is the difference that you are able to find out here? The difference that is going to happen is head minus tail is going to be n, here it is, again n minus 2, then n minus 4, like that. So it is going to happen here n minus 2, and here it is n. I am taking a mod, so don't worry about it. So you can see very clearly that the difference never becomes n minus 3. Difference never becomes n minus 3. So you can say the result that you are going to get is, where is the result? Here. So this will be the result, B. Let's take another question. The question is, if two coins are tossed at a time, at a time, and at least one of the outcome, I'm giving all gate questions, okay? So you must practice all of them. At least one of them, one of the outcome is known to be head. Is known to be head. The probability that the probability that both outcomes are head is. What is the probability that you will get both the heads? Options are 1 by 3, 1 by 4, 1 by 2, and 2 by 3. Take a minute time and solve it. Why don't we do one thing? We have two coins tossed at a time. Okay, so two coins are tossed, then and it is known that one of them is head. So if you tell that here it is two coin tossed, what is your like a normal understanding that my sample space will be head head, head tail, tail head, and tail tail. But this is going to be wrong. Why? Because it is known that one of them is always head. So this tail tail is not possible. Understood? So my sample space actually becomes either head head, head tail, and tail head. It is not tail tail because one of them is definitely head. Got it? So you can see now that my probability of event E, which is telling you that both heads means what? One of them is head, another head will come when you can see you have only one event. So that is going to be 1 divided by the sample space is 3, so 1 by 3. Got it? If both head has to happen, the only event that is happening is this one, head head, out of 3 events, because one of them was definitely head. So we have done that. I hope you have clear understanding of this. Let us take another question. Question is, a fair coin is tossed till a fair coin is tossed till a head appears. Like you are keep on tossing a coin until you get an head, okay? For the first time. For the first time. The probability that the required number of tosses is odd. That the required number of tosses is odd. So what is the probability that you have to toss the coin to get head first time? That is odd number. Okay. So can you tell me just try out a minute and see if you can solve it. All right. What is the possibility to happen this particular event? So it is possible that you can get first itself head, right? Next is, let's say you did not get in the first event, then what will happen? Either you will get tail, Now, the probability that the required number of tosses is odd, it means second time also you will get tail, then only you have to get head. Like you have to get always odd times, right? Then it can happen the same way, tail, 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 and then fifth time it is head. Like that it will keep on happening. So your event is like this, either you get first or the third or the fifth or the seventh, like that. Understood? Now what is the probability of getting head? So getting head probability you know already, probability of getting head is equal to probability of getting tail is equal to 1 by 2 in a coin, right? So first one it will be 1 by 2. Next one it will be 1 by 2 into 1 by 2 into 1 by 2. Next will be again 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. So like that it is happening. So you can say that I have to sum all these lines to get this particular result. Got it? So you can write it down 1 by 2 plus 1 by 2 cube plus 1 by 2 to the power 5 plus like that up to infinite times. Can I do one thing? You know already this is a GP, geometric progression series. So if you want I can take 1 by 2 common as well. So 1 by 2 let us say I take common. Then it will happen 1 plus 1 by 2 square plus 1 by 2 to the power 4, like that. What is the GP series for this particular event? So you know it is like this. 1 by 2 into 1 plus x square plus x cube, like that it is, right? So can I do one thing? Can I do one thing? I will write it something like this. 1 by 2 into 1 plus, let us say 1 by 2 I consider as x, then what will happen? 1 by 2 square, 1 by 2 square will happen 4, and then next it will happen 6, right? So 1 by 2 square cube it will happen, right? So like that it is going to happen. Now I can write it down as 1 by 2 into 1 plus this is x plus x square plus x cube, like that up to n times, where x is what? 1 by 2 square. Got it? And you know already 1 plus x square plus x cube, what is the result for this? That is 1 by 2 into 1 minus x to the power minus 1. So that is going to give us 1 by 2 into 1 minus 1 by 2 square to the power minus 1. That is going to come up as 1 by 2 into 1 minus 1 by 4 to the power minus 1. That will be 1 by 2 into this is 3 by 4 to the power minus 1. That is going to be 1 by 2 into 4 by 3. So that is going to be 2 to the 4, that is 2 by 3. So 2 by 3 is the answer, right? So this is how you have like solved this particular problem by yourself, right? One more method is there, like for geometric series you know already what is the result. Let's say you do not remember this 1 plus x square, like that you do not remember. Then you know already that if this is the like GP series, what is the formula for this particular GP series? That it is a by 1 minus r, where r is less than 1, right? So for that case what will you do? You can say that this result directly I can write it down as 1 by 2 into a is first term, that is going to be 1. So 1 by 1 minus r is nothing but your x, right? So x, that's all. So this is the reason 1 by 2 into 1 minus x to the power minus 1 had happened. Okay, got it? So you can say 1 by 2 into 1 minus x to the power minus 1. Directly I have written. But if you do not want like this, you write it like this: a by 1 minus r, and put r as x and a as 1, because this first term is 1. Why don't we take a very beautiful problem? So let us take one more problem. Question is, the probability of 53 Sunday in a leap year is. Probability of 53 Sundays in a leap year is. Options are 1 by 7, B is 2 by 7, C is 3 by 7, and D is 4 by 7. So can you solve by yourself and tell me what is the result for this? So since it is leap year, so what will happen? In a year, 366 days will happen. Right. So you know already we have weeks, that is 52 weeks into 7, that is going to be 364 days, right? And plus 2 additional days, right? So these 2 days you are going to get either Sunday, Monday, Tuesday, Wednesday, like that, like in a row, right? So the possibility of these 2 days that will happen is what? You will get definitely 52 Sunday, that is definite, right? By this equation. But out of these 2 days, how many times Sunday will come, that we will see. So the possibility is either it can be Sunday and then Monday, or Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, and Saturday, Sunday. So you can see we have total 2 number of times Sunday and Sunday. So the probability of getting the event which is 53 Sunday means what will happen? You will get 2 times by 7. Got it? All right. So let us keep up to this, and we'll solve more problems and like more understanding about probability in our next session. Thank you.